Hello learners, allow me to take you through solving quadratic inequalities. Remember the standard form of a quadratic equation, which is ax squared plus bx plus c is equal to 0. Now we are dealing with the quadratic inequalities. Instead of an equal sign, you will see either less than, greater than, less than and equal to, or greater than and equal. Those are the signs that you will see when dealing with the quadratic inequalities. Let's look at the example on how to deal with the quadratic inequalities. Solve for x. We are solving for x now in quadratic inequalities. A quadratic inequality is given as x squared minus 5x plus 4 is greater than 0. So now we'll look for the values of x that will satisfy this inequality. When looking at this inequality, you can see that it is in standard form. When we say it is in standard form, it is in standard form of a quadratic inequality such that we can read the value of a, the value of b, and the value of c. A is equal to 1, b is equal to -5, and c is equal to +4. After having the values of a, b, and c, we say learners insert the quadratic formula in the calculator and substitute into the quadratic formula in your calculator. So this is the quadratic formula that you are using. It will then give you the values of x as x is equal to 1 or x is equal to 4. Then we call these values of x the critical points. We call them the critical points. And remember that before we went to a calculator and substituted into the quadratic formula, we skipped a step whereby we're supposed to be factorizing this quadratic inequality because we avoid thinking too much, trying to test so many factors. So by getting the critical points, it's easy now for us to predict the factors of this quadratic inequality. So the critical points that we are having as x is equal to 1 or x is equal to 4. We then now draw the number line of the x values. So after doing that, so our inequality has a greater than sign. So we put two open dots because we have two critical points. So if we had greater than and equal to, so our dots will be shaded, but now it's greater than. So our dots are open. If it was less than, our dots will be open as well. Alright, now let's put our critical points 1 and 4. Let's test the values in each interval. You can see the intervals, we have 3 intervals in this case. There is an interval of the values of x that are greater than 4, the values of x that are between 1 and 4, and then the values of x that are less than 1. So now we just test one value per interval. If you test one value of the interval whereby the values of x are greater than 4 and you substitute into the equation using your calculator, you will find that the answer that you get is greater than 5, meaning that this interval satisfies the equation. And also if you check the values that are less than 1, you substitute one value into the inequality, you'll find that it gives you a value which is greater than 0, meaning that those values are satisfying the inequality. Then therefore now we need to write the solution to this. Therefore our solution to this becomes, so we have the values of x that are less than 1 that are satisfying the inequality, or the values of x that are greater than 4 that are satisfying the inequality. X is less than 1 or x is greater than 4.